Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome back again to online NPTEL course on structure, form and architecture, the synergy. In this lecture, lecture number 30, we will be discussing on pneumatic structure. Previously in lecture number 29 and few lectures before that, we have discussed the structure of special in nature and with different application for covering large span and also reduce the dead load and all. So, pneumatic structure is in the same category. Again it will solve the purpose of covering large span with minimum weight, but there are some few disadvantages as well. So, we will discuss in this presentation. It has a relation with the previous one like where we discussed about membrane structure. So, in one of the form that we discussed that inflatable, that is the structural form being created just to with the air pressure, and that is one of the starting point of this pneumatic structure. So, let us start this particular lecture and go through the different example to understand the structural application in a better way. Now, before I read out anything from the slide, so let us see this particular boat. Okay, so we all are familiar with this, some of us having the experience of using it, or maybe we have seen somewhere in some documentary, some video, some movies. So, this is something where it is very thin material, and when we put air into it, due to that air pressure it creates a volume, and it can float, and it is so light, so that it is stable as well. So, the lifeboat or maybe the life ring, whatever we see, this is having the similar principle. We do not need to go that far. Even we all are familiar with the balloons during the birthday celebration or during any celebration we have seen. It is basically a very thin membrane rubber material, and when you put air, so it will get the volume and it will give a shape of like the way you desire. Like sometimes you can create the customized shape of a heart shape, or maybe something a tubular shape, or maybe just a spherical shape, or sometimes it may be egg shape. So, that is one of the example of the pneumatic structure. So, it is actually the structure, that thin membrane, enclosed membrane that is filled with air and give the form, and that also the stability. So, due to the balance between the interior and exterior pressure difference, the form is in existence. The moment you release the pressure, it will be deflatable and deflated, and then it will be just thin membrane, nothing else. So, here pneumatic structure are flexible membranes that I already mentioned, that derive their stability from air pressure. So, two things, one is thin membrane and then the air. So, if we combine the in a perfect combination, then we will get the the stability, the form. In pneumatic construction, pressure difference between enclosed environment, that means the interior space, and the exterior are responsible for giving the shape. So, this is the main fundamental of pneumatic structure. In this case, most of the cases the synclastic curvature, means the doubly curved curvature being used where the curvature is in the same direction, that we have discussed in detail in the previous lecture, like for the dome and other thing, the curvature like doubly, if it is doubly curved curvature, but they are in the similar direction, same direction rather. So, these are synclastic, but anticlastic curvature being also being created, but for that the purpose is something different, the system, the methodology will be different. So, we will try to cover that as well. The membrane's minimal weight and small size when deflatted. First of all, weight is minimal because thin membrane you can see that the volume that being created, that can be carried by one person, okay, when deflatted, and you can fold it and you can put it in a bag, a small size bag. So, this is the advantage of this, and when deflatted it can be easily manipulate, like you can give any enclosed form or something to carry and the transport. So, this is one of the advantage that we discussed at the very beginning of this presentation. So, before we go and discuss in point of the architectural buildings that or maybe any structure that use this. So, this is I think very familiar to all of us. Maybe some of you have experienced it, or maybe you just watch the kids playing over it. So, this is something which is very common in the fairground, where the kids they are jumping over it. But what structure it is? It is a very perfect example of pneumatic structures, where these are perfectly stitched, those color membrane and cloth, and the air, through a air pump the air is inserted to this, and it making a balance between interior and exterior air pressure, so that it is giving a particular shape. And as because it is placed in a coarse form, so there will be no such tolerance or something like a turbulence to this structure due to the heavy wind, and also people will jump, and that is because it is for the kids. So, if you calculate say 10-20 kids, so their weight is not that great, so that it can easily hold the load. So, this is one example of the pneumatic structure. So, from one particular part, it is a control pressure that we have to provide. So, it may be a continuous one, or it may be just filled once, and then if we can have a leakage proof material, so then we do not need to do it. Okay. Sometimes in the CT we see that some weak size balloon, okay, that is flying over that, and it is showing some ad of some company or something. So, again it is the structure, the spherical volume, or sometimes even not the balloon shape, it may be of a plane shape. Okay. So, it plane shape something is floating on the sky to give a ad. So, these are example of the pneumatic structure where the due to air we can get it. Even not only this made of cloth, or maybe made of this plastic, made of rubber material. So, let us take another example, it will be more clear, and then we can understand in a better way that I was talking about this particular safety ring for the emergency purpose we can use it. So, this is again a structure where the air is injected to that. Then this is something where it is nicely depicting what I wanted to say, that when it is deflated position, it is nothing but a small, like very thin membrane, very lightweight, but when you put air to it, it is giving you the volume that you require. But if you release it, it will automatically be in its original position. But during this the deformation, like here in this case of balloon, we have seen that many a cases, like we blow up a balloon and we put it for 10 days or something, and then automatically it is coming back to this shape, even it is closed, because there is a very slow leakage through the surface and there will be permanent deformation. But whenever you apply it with a good membrane or having good strength, so probably this will not occur. You can reuse that material in many places. So, for any temporary fair shop or something that you want to give, any display area, so we can take help of this kind of structure where air will be used as the main structural support to give and create the form. Now, here this is nowadays very popular, and even in television, even in all in different YouTube videos, even in your websites, okay, e-commerce websites, you will get that this kind of multi-purpose furnitures which is just made with some membrane, and with the air inserted to this structure will give you the form of a sofa or the bed. So, this is something very important, and when you just remove it, you can fold it and you can put it in a very concise or small area, which is very much effective. So, optimal use of this structural membrane, or what the membrane structure with the air and all, is very useful nowadays. Now, coming to the general characteristics, looking at this example, that these are very common, I do not really think to you get surprised to know something about that. So, light weight, definitely it is very lightweight material because of the thin membrane and all. The safety point is another important issue, and now it will have two kind of answer to it. So, when it is a small scale very close form application, so it is safe because it is just put with the air. So, there will be not much dead load. So, collapsing of this structure will not really affect much, but again the safe when it is being applied in the open area and there is a heavy wind flow. So, then if the air is not properly maintained or counter the additional force, that sudden load applied to that structure, that may cause some damage, and that will not be very comfortable because the interior fixture and all that will have some deformation. The quick erection and dismantling is definitely the case. So, in case of the sofa, perhaps if you have not, then you just go through the video of this inflatable sofa or bed, you get that this is a very small like material, folded material, and there is a point that you just about the electric air pump, and then it will just inflate, and then they will create the volume. So, slowly it will give the form. So, it is very quickly can erect. Even that example I have given for the this particular facility for the kids, there also it is to be done. So, we do not need to transport the exact structure from one fair ground to the other, we can just remove the air and we can fold and we can easily transport. Now, coming to the economy, as because it is having very less number of support or very strong support. So, it is economical obviously. So, what you need some anchor to hold it, to ground it, so that it will not blow away with the air or something. Good natural lighting, if we use some translucent material like the membrane, in membrane structure we have discussed the translucency is one of the criteria to select the membrane. So, here it is true for this case as well, because it is also the membrane. The only difference there we have given support with the mast and the tensile cable, but here it is only the air. So, it is having the good natural lighting. The human health, this is an important case, because for maintaining the shape you have to give constant air supply to this. So, there will be some pressure difference, and who are inside to this structure, they should also be getting adjusted with the pressure difference from inside and outside. So, we cannot really increase the pressure so much, or you cannot make a vacuum, so that it will get it will put some effects on the human health. So, that you need to take care when you apply this kind of structure for any purpose. Normally, this kind of structure being made for like convocation hall, or maybe sometimes for exhibition hall, or maybe small kind of some interesting public places, that I will show you some of the pictures of that kind. Now, coming to the components, what exactly the components are. The typical components of a pneumatic structure is, one is envelope, is nothing but the membrane that we discussed earlier, the cable system that will anchor everything to that, the pumping equipment, because the air is the source of making the structure stable. So, the pumping equipment, then entrance, we can create a balloon, but the main problem we cannot go inside it. Okay. So, in order to do that we have to have an entrance, and that should be air locked. So, that should not release your the pressure. So, that we need to take care of that, and constant monitoring on pumping and overall pressure difference from outside inside to be maintained. And the foundation, in order to make the stability, so foundation is also required, where like the end point maybe through cable it is attached to a particular post, or it may be with some foundation, initial foundation on main piers we can just add on. Coming to the materials that can be used for the envelope is the membrane material. So, again it can go with the fiberglass, PVC fiberglass, the polyester, then ethylene or tetrafluoroethylene, that where we have discussed about PTFE or maybe ETFE, nylon. So, this kind of material which will have enough strain to carry and having good strain to weight ratio, that can give some advantage for this. And for the anchor system we can use the steel cable just to hold it. So, we just hold it from a point and we just make a tie at the end, or you can use the ballast. So, where this can be supported with a temporary arrangement of a few bags of cement, or maybe it is a permanent post or maybe a very solid post being just erected there and getting connected with this structure. Move forward, the basic typology of pneumatic structure, we have two kind. One is your air supported, which is normally also low pressure, and other is your air inflated. So, we will discuss one after another. So, low pressure means where normally, before I go, so we create with a single layer of the membrane and we put air and we get this volume. Right. In this case, the low pressure to be maintained, the pressure inside is slightly more from outside. So, if it is P exterior and this is P interior, so P interior is slightly more than P exterior, and that is why it is holding the shape. But as because that will be habitable, so we have to also take into consideration the pressure that one human can hold, and that to be calculated. Now, where the air inflated is not a single layer, it basically the two layer of the surface, the membrane, and air is not injected directly to the shape, it is injected in the medium. So, between two layers the air is inserted. In this it is basically very high pressure. So, if we consider this is as your Pi within the system and Pe, so then Pi is much greater than your Pe, and there is no effect on the human who are inside to this, because it is within that. So, that this is giving better stability. So, for that kind of inflated we cannot have a continuous two layers. So, in order to give rigidity, what we can do, if I just want to draw a barrel vault like this, so instead of a continuous one we have the segment. So, individually we just put the air and then we get this facility like this. So, this is making a cushion kind of thing in between. If I make a cross section, so basically it will be something like this. So, a series of that is connecting each other is creating this particular air inflated or high pressure pneumatic structure. Now, coming to the air supported, whatever we discussed, let us just go through this. It is single fabric layer enclosing a space in form of domes or similar shape. So, it can be of dome, it is very easy, or else we can also go for a barrel. So, where like it is not the dome we have, and at the end we have a closed form and then the entrance to be made. The fabric is supported by inside air pressure. Obviously, the low air pressure makes air supported structure more vulnerable to the flutter or underwind load, as because the interior load the air pressure is slightly more than the outer. So, if anything implied heavy wind blow and all, so this will not really help. So, it cannot take the hold of the volume. So, it will take different shape like this, which is vulnerable. So, in that case compared to that, as because it is high pressure, so it can hold it in a better way. Since the usable space is under air pressure, door openings must have the airtight air locks to prevent any leakage. Air supported structure require continuous air supply, usually with standby electric power generator to run the fan continuously, so that air is maintained, because whatever the air loss from the opening the door or and that is why here we use the revolving door. So, that can be maintained. So, this is the example where you can see that how this is the entrance and this is the support grounded, and this is a single layer balloon kind of structure, and this being made. So, here this is something that I have picked up from the internet. This is very easily a very popular image that you can get, and the source is given. So, you can get more information about that. So, in this case you see that the structure, the whatever the snow road or maybe the rain road, so they can easily be drained off because of the synclastic curvature, and the interior pressure is holding the overall shape, and the wind load which is lateral, which is really vulnerable if we have very little pressure difference, and at the bottom it will have the tension. So, like it is the all sail structure, at the bottom we get this tension force or tensile strength as the structural phenomena. So, it is not really different from that, it is also having the tension. Coming to the next category, that is the air inflated pneumatic structure. So, it is hermetically means the air tight. So, this is the property of the air tightness, enclosed volume that are inflated under high pressure, much like a football or to provide stability. So, it is enclosed. So, for football, like this is a particular cell and we put it. So, it may be any such balloons like structure. So, there are different cartoon characters nowadays available. So, you have to blow, and then there is a particular point. So, where you can enclose it and you can lock the air and it can give you the shape. So, it is available like in terms of different cartoon character, different playing instrument and many. So, that is one. Then the tubular or cushion form being created in this case, and high pressure is maintained. So, it is basically something like this. So, before we go further, let us show you this example. You are familiar with this facility as well. So, this is something I have picked up. So, these are the plastic air pocket. Here I have just removed the air. So, it is very thin, I can fold it, right. So, these are available when you order something from online. So, you can get this particular packaging. So, this is with very small space, I can just hold it, okay, it is nothing. But at the same time, when I inject here, when I have not released the air, so it is giving a volume. So, you can see the volume and it can easily carry the load. So, this is very flat, but you can have similar structure where you can give some bend and all. So, only with the air it is giving some cushion which will really give the shape, will hold the particular shape. So, the difference between these two, they are of the same material, but only difference is here it is I have removed the air, and here air is within this particular plastic. So, it is giving this cushion. So, this is one example of this your air inflated pneumatic structure. So, where is kept locked between two layers. Okay. And now, without air pressure they would have no stability, that already I have explained with this, where I can just crash it like this. The air inflated structure also requires some continuous air supply to maintain the stability. It is same like during that particular process, there will be slow leakages. So, in order to maintain that, we have to put the air, not maybe regularly, even like I can give you the example of this the cycle tube. So, when you pump it, like if your tire the tube is very new, so maybe it can run for another 2-3 weeks or maybe 1 month, but at the same time slowly even we do not use it, we put it somewhere in the sun and all, there will be slow leakages. So, then again we have to fill that with the air. So, this is a similar thing, but with the membrane, not with the rubber material or the tire that I just mentioned. So, this is one example. The difference between that, you can get this different cushion, and this example you can get if you have used some cartridge, laser printer cartridge and all. So, that is inserted within some padded or something, like you get a packet where the outside you get this kind of air inflated structure. So, that it will give the proper cushion to the cartridge, so that there will be nothing, no damage during the transport and all. So, in this case if you see that the only difference we get that 2 layers are there, and then the air is in between and they are balancing each other to this, and here we can get the high pressure compared to the other the exterior the outside pressure, and there will be no such impact on the human related thing. The earlier, as because there was a single layer, so that was the problem with the additional air injection or the creating the vacuum and all. So, it is basically the putting more air into it, not the vacuum. Vacuum will squeeze this down. So, when you want to dismantle, you have to do that to get the what the vacuum can work, to remove the air from that. Now, let us have a quick test on what we understand from this air inflated and then air supported. So, here are some pictures that is randomly placed and a number is aligned given to that 1 to 8, and let us understand what are those, like which category they are. Here the choices are only 2, one is your air supported and one is air inflated. So, just have a look into this and just try to give an answer, okay, and maybe spend another few seconds to it, and then I will show you the answers and you match how much correct you are and to know what exactly it is. You got your answer? Okay. So, now let us just check how much correct you are. I think most of you are 100% correct. So, let us understand this. So, number 1 is called air supported dome and vault. Why? We should understand why. We should not believe on the text that is written. So, as because this is single layer and filled with the air, so it is in the first category. So, air supported dome and vault. The second is another one, but here it is the vault structure, because this is something where we do not understand exactly the volume, the cross section. So, it may be something which is evolved and get a form of a dome, or may be extended, that is a vault. So, this is one. The second was is strictly a very simple layer, a single layer is there. So, we are supported. So, I think you both of the answers got correct. Now, coming to the 3, number 1. So, here it is something where air supported vault with support cables. So, what exactly, like when you have a large structure, okay, and made of the 3 members, so it may sway, and to give the some support, it is not 2 layers, but we just tie it up with some cable. So, we fix it so that it will maintain the shape. So, it is very useful tool that with the cable or rope we give this particular additional stability, so that it will not sway or it will not deform much due to the wind. So, this is again the air supported vault with the support, and then this is similar, the fourth one is the multiple dome of that, again it is air supported. Now, coming to the 5, it is very clean and crystal. If you take this example, it is similar to that. If I hold it, so it is giving the same shape and air is inserted, air is locked between 2 layers. So, it is air inflated structure cushion, and then similarly when you just make multiple. So, I just make multiple of such and make a form, and they are actually connected to each other. So, we will get the form of this number 6, this is basically air inflated vault. and we can go with the number 7, where it is not in a wall direction, but in a concentric ring, and it is forming a dome of air inflated, and here it is a multiple dome where the 2 layers being done. So, there is additional support, in this case the entire thing to be given. So, it is very interesting to compare the 4 and 8. So, the top is same, but here it is a single layer. So, it is giving the volume of the wall as well as this the base, and here it is just the support. Coming to the example of this, so this is one example of that inflatable tea house, where the membrane is being made like this. Here it is the Eden project, basically this is made for a greenhouse for the botanical garden purpose. Here Yorkshire Diamond Pavilion, again these members they are actually filled with the air. So, in this case this example is for the air inflated. So, these members they are full with the air to give this form of this structure. Now, coming to the Fuji Pavilion, and that too in 1970. So, this is something where again it is air inflated structure that club together and create this beautiful pavilion, the exhibition space. Similarly, the US pavilion in Osaka in 1970, the same category. Here it is the similar thing where the membrane being created, and then for additional support that being created with the support frame. Coming to the application of this, so for the sports and recreational centers, exhibition, convention center, greenhouse, whatever the examples we have seen, maybe for any other demonstration also we can get this kind of help. Now, coming to the advantage of that, again it is light in weight, similar to the membrane structure, good for large span without internal support. It is true for all this spatial structure here. Rapid assemble and disassemble is definitely you inject the air and you remove the air, that is all. Low initial and operating cost, as because of like hardly any such heavy materials being used there. Easy to transport when deflated is similar with the example I have seen, that suppose this is the structure, if I want to put it in my pocket, maybe it will take much time, but I just deflat it, the same material, and I can hold it, I can put it in my pocket. So, this is very simple example, you can just enlarge the scale and you can get that the statement is very correct, that we can easily transport when the overall system is deflated. Coming to the disadvantages, yes, it needs continuous maintenance and excess pressure to maintain, especially for the air supported, where you have to maintain the pressure in a controlled manner, so that there will be no adverse effect on the human body who are really enjoying the interior space. Continuous fan operation is required to maintain the pressure. So, a backup should be there, it should not be something like only it is supported based on the electricity supply. So, then that may create some problem. Insulation is poor because of the thin member, definitely this has some resistance, poor resistance to the thermal thing or something, but yes, definitely if we go for some good material, that this poly tetrafluoroethylene or some coated material, that can be taken into in a greater extent, that can ease off some of the problems. Service life is relatively short because each time you inject air and then remove. So, it will not have a lifespan of a concrete frame structure or many cell structure, but yes, for portable thing this is very useful, and the probable application that may we think for the rehabilitation center, where for the we have to locate many people to make, and we have to erect it very quickly. So, we can transport this kind of material and we can create a state, so that the people from the disaster area can be easily rehabilitated in that place. So, this is the advantage of this pneumatic structure and can be applied. So, with some of the disadvantage and advantage, we should take a call what is our purpose, and accordingly we take a decision on which kind of structure to be adopted and the form. So, this is end of this particular lecture. So, in the summary is basically everything is explained. So, basic 2 type is your air supported and then your air inflated. So, air supported is basically a single layer, air is inject and with the internal pressure it is holding the every load, and where it air inflated. So, two layers, the air is actually locked in between two layers and a very high pressure is maintained to create the shape, and remaining the membrane characteristic is similar to that. Is the application, and application is already I have discussed in different exhibition hall, pavilion, and this is the case, and very light material, easy to transport, easy to assemble and disassemble, these are the advantages. With this I conclude here. This is the reading materials. Again you can go through the web links given for the relevant slides, so that you know more about this subject and get better idea, better examples. I have given some examples, you can also add more example, you can give me that feedback, you can put it in the forum. So, we will discuss over it. With that we will move forward in the next lecture, is basically lecture number 31, that talks about structure and architecture form in windy areas. So, now we will move through a specialized design for different kind of environment, windy or earthquake prone or flood time to time, and we will discuss more on this lecture. Till then I really thank you to take part in the course, and we will be meeting in the next lecture. Thank you.